welcome. Please find your seat for this last presentation before lunch break. The team from Intezer has stayed with us and will be taking us into the world of a friend near and dear to many of us, Cobalt Strike. And yeah, I'll give it to Avigayil and Ryan again.
Great. Okay, so hi everybody. Welcome to the Rise of the Vermilion cross-platform Cobalt Strike beacon targeting Linux and Windows. This talk is based on a research we conducted during August 21. I'm Avigayil. I'm a product manager at Intezer. Before that, I was part of the research team, and I focused on malware analysis and threat hunting.
I'm Ryan, also a security researcher with Intezer. You might think I look similar to the last guy in the talk. We're related, so we are. And in previous roles, I was a researcher in Anomali's threat research team and a security engineer, securing cloud applications on the entire organization. So a quick sort of agenda for what we're going to go through, very lightweight. But we're going to talk about Cobalt Strike first. The reason why we want to talk about that is that, this is the reason why Vermilion exists, and so it really helps to understand what Cobalt Strike is, who uses it, why it's being used, why it's so popular, and then why it gives birth to other malwares that are inspired by it. Then Avi will start talking about the Linux malware threat landscape. This kind of combines with the Cobalt Strike sort of to give birth to Vermilion. And we'll talk about that. Avi talking about the threat landscape. It's the incentive, the march towards cloud, and why there's an incentive to target Linux. So then we'll talk about the actual malware itself, Vermilion. We get quite technical. Avi will talk about the background first of like how we discovered it, what we found odd about it, how it came onto our radar, and then I'll go deep into sort of more technical analysis, maybe show a bit of code and stuff. So that'll be fun. And then we'll have a discussion around that, and then just sort of a wrap up and hopefully talk to you guys and get some questions from you. So what is Cobalt Strike? It's marketed as software for adversary simulations and red team operations. That might not be too descriptive for you. It might sound like some of the marketing or sales people downstairs. But the way that I would phrase it, it's a malware framework. It doesn't just include the malware, but it includes the ability to generate payloads and the command and control infrastructure behind that. So really, if you want to get up the speed or start using a really good malware framework, it's all in one. So it is. Simply, there's sort of more components in this, but the most basic components really to be aware of is that there is the beacon. And the beacon's what you would sort of consider the malware side. The beacon is what runs on an infected host, or whatever your target is, or if you're pen testing for your own organization, some of your own internal computers. And that can consist of two different components. One is the stager. The stager is optional, but it's used quite a lot. And basically, it's a small snippet of shellcode that will reach out to a command and control server, and it will pull down the backdoor. And the backdoor, pretty much, it's the full malware. It's the thing that controls the machine, will contact back to the C2, get controls, really what you're going to perform your actions on objective on. There are things called loaders. What loaders are they're sort of small snippets of code. You get them from many, many languages, many scripts, things. But basically, a loader is a snippet of code that will execute either a stager or a backdoor. There's what's called the team server, pretty much the C2. And there is the client, and that's what you see in the screenshot there. The client is what you use to log into a team server, but it's also what you use to sort of generate the payloads and where you run commands from. Think of it more as your steering wheel for Cobalt Strike. It's extremely popular. Why? It's got great features. Pretty hard to detect. The stager and all typically run in memory. It's easy to configure. There's a GUI and everything for it, so you can point and click. There's no sort of like you don't need to use like a fancy terminal, kind of if you want. You can generate a plethora of payloads. You know, like I said, the loader, it has many, many languages. You can even generate like sort of documents, emails, things like that. That's, you know, for whatever your target is, it usually has something pretty sort of bespoke for it, and then you can do it. The command and control is handled, so you don't really need to do too much to set up your C2. Just sort of run a script, and that's all sort of set up for you. You don't need to deal with like network communications yourself too much. And it's hard to attribute, so it is. And the reason why I say that is that there's so many people using Cobalt Strike that it creates a kind of Spartacus effect. And you know, a lot of time you really don't know who's behind it, or you can't attribute based off Cobalt Strike alone. You have to do other things, such as like the C2 and all. If you remember the Ukrainian cert was talking here a couple of days ago, it was the second most popular malware, I believe, that they had seen. So who are the users behind it? They're red teams and adversaries, we call them. So the intended targets, and the intended users are the red teams. You know, these are people that buy the product, it's licensed, they have permission to use it within their own organization. They're really using it to find you know, vulnerabilities, or basically conduct attacks within their own organizations, see what you can learn, be within the mind of an attacker, and then start to patch that. The other side, adversaries, black hats, actors, whatever you want to call them, bad people. These are the people that usually get a cracked version of it, so no license, you know, no permission to use it, and they use it as, you know, a malware. And so where do adversaries get Cobalt Strike from? Pretty much every time a new version of Cobalt Strike is released, honestly within like a week, a few days, couple of weeks, you'll get a cracked version somewhere online. It's honestly, it's trivial to get your hands on, so you can get it even on sort of GitHub, like just screenshot a tick, like you can, actually, I think you can even just sort of Google it, and you'll probably get it in like the first couple of search results. But you can also get it in things like dark web forums, sort of markets and all. Honestly, extremely trivial to get your version, to get your hands on a cracked version of Cobalt Strike. So in the news, honestly, I could have picked one of a million, you know, sort of things. Like you just type it into Google News and you get pages upon pages upon pages. I could have updated this probably for last week. You know, so you see things, Russian APT hackers, you know, using target sort of diplomats in Europe, things like that. Yeah, it's all over the news. No, you'll get it from the lowest script kiddie, even up to the highest sort of nation state APT using this, and yeah, it'll make the news. So, what about Cobalt Strike and Linux? Officially, there's no Linux version, and the maintainers of Cobalt Strike, Help Null Systems, they released a blog saying much as so, this is a Windows-only payload. But, you know, like programmers are smart people, tech people are smart people, that really doesn't stop them from making something that's able to communicate with the server. So a few sort of notable examples for Linux versions of Cobalt Strike. Open source project called Geekin. It is a Golang version of the Cobalt Strike beacon. There's the Cross C2 framework. What's probably my favorite is that a user on Twitter, he was able to run the Windows version of Beacon using a Wine emulator on Linux. So yeah, you can probably just use Windows on Linux. I don't know how easy it is to install Wine. So yeah, you can get it for Linux. So now we're probably on topic of Linux.
Thanks, Ryan.
Thank you very much.
Cool, so now that we have some background about Cobalt Strike, let's talk about the Linux malware threat landscape. So the Linux market share in the desktop world is really, really low. It's approximately 2%. However, when speaking of cloud servers in general, the situation is quite the opposite, where Linux is a predominant operating system, which makes sense because of the nature of this operating system. Now, this really affects the malware threat landscape because we see many, many coin miners and botnets, which are designed to take advantage of the victim's computing power. And the developers behind of these malwares, or the adversaries, that deliver these malware just want to get to as many victims as possible, and these attacks are usually not targeted. Now, we also have ransomware. They will usually be more targeted, and they will be delivered to file hosting services such as QNAP or to VMware ESXi. And lastly, less frequently documented are backdoors. And backdoors will usually be targeted. And historically, they will be developed by a nation state. Now, the nation state that have been publicly known to be to deliver malware to Linux are Russia, North Korea, and China. Now, an interesting fact here is that many of these malware written from Linux by nation state has at least one other version to target another operating system. So, for example, for Russia, we have APT29, they have Wellmes. Wellmes targets Linux and Windows. For North Korea, we have the Lazarus group. They have DACL's tool. DACL's targets Mac, Linux, and Windows. They also have the Manuscript tool that targets Linux and Windows. And for China, we have the Winty group. They have a backdoor for Linux and Windows. And also the BlackTech group, which have TS Cookie and Plead. Both of them were first found targeting Windows, and later on, they were targeting Linux. So yeah. Okay, so now we have background about Cobalt Strike, about Linux malware. Let's connect all the dots together and talk about our research. So one day we got this hit from our threat hunting tool about this ELF file. We uploaded it to our system, which is Intezer platform, and we found three interesting things. First of all, again, this is an ELF sample, and we saw that it shared strings with Cobalt Strike. Now, as Ryan mentioned before, Cobalt Strike has no official version for Linux. Okay, so this was really, really interesting. Second of all, we saw that it had a high percentage of previously unseen code. Okay, the Vermilion strike that you see over here, this was after we marked it. Okay, this code was unknown. Now, I'll explain what Intezer do, so what I'm telling you now will make sense. Intezer has a very, very big database of previously seen malicious and trusted code. So every file that is uploaded to our database will be then divided into small chunks of code compared against this database. And based on the result, we can tell if this code has been seen before, what the file is it malicious, is it trusted, what family it is, and so on. So the fact that it had no previously seen code is a really strong indication that it was written from scratch. And lastly, it had different network-related capabilities for communication, DNS resolution, and so on. Now, looking at this file in VirusTotal, it had no detection by any other security vendors, which is not really a decision differentiator when speaking about Linux, and I'll touch upon that later. However, it had an interesting name, X11JTK. Okay, so X11 is a graphical environment, JTK, widget libraries. It's a thing, okay? However, when we search the exact name in VirusTotal and in Google, we got no hits at all, okay? So this was kind of interesting. And lastly, we saw in VirusTotal that it got hits by Florian Ross Yara rules for Cobalt Strike, which kind of aligns with the string reuse that we saw before at Intezer. So all of this made us really, really happy as researchers because we know that we have something interesting in our hands. And then we continued to research this, and we dived in technically. And Ryan will explain you.
Thank you very much. So the fun part, I sort of deep dive into Vermilion Strike. We'll show some code and stuff, so let's jump into it. So very simply reduced into a very simple flow chart, Vermilion is executed. It will daemonize itself in the background, split. It will decode a configuration. You import a public key that will sort of use for encryption communication. It'll fingerprint the machine and then just start the command and control loop. honestly kind of simple. And so let's start with the configuration. Simple Zor cipher, pretty normal for Cobalt Strike. What we noticed is it used what was a pretty standard key, hex 69. And yeah, we see that in like a lot of the Windows versions for Cobalt Strike. What was really, really funny, interesting, is that you can use standard tools, for parsing the Cobalt Strike configuration on this too. So, imagine you're expecting to give like a Windows file, you can give like a ELF file, and it'll still be able to parse the configuration. And something very interesting is that you'll sort of notice that there are Windows artifacts, that show up in the Linux version. So, if you're ever trying to look for suspicious Linux files, a nice flag to see if it has like some Windows stuff inside it, because it kind of doesn't make sense. And what I'll just highlight up there in the corner is the C2 address there. You can put multiple within the configuration of Cobalt Strike. So fingerprinting machine, again, super easy. Get the process ID, get the kernel version, network, user, build it up into a big string, encrypt that string using the RSA key, and then base64 encode that. So if you're doing any sort of network traffic kind of monitoring, like you won't be able to detect, those suspicious strings going across. So it'll avoid like some sort of defenses and things like that. Command and control. It was a DNS and HTTP beacon. Primarily, it was DNS, but you can sort of swap, so you can. So commands are received over address and text records. The way it goes, think of address kind of like a GET request that just sort of points you to do something. But if you need to give data down to Vermilion Strike, you can do that in a text record, like say, give me this file or sort of this directory, where you need to tell it something. Also, interesting enough, there's a branch of code within Vermilion Strike that deals with ICMP communication, but there's no way to actually get to the branch. So possibly the threat actors, they were thinking about adding a new protocol for communication in. Maybe it's still in development, or maybe they sort of just stopped halfway through and just thought, the DNS and HTTP is good enough. It isn't sort of detected or anything, so maybe there's no incentive to keep going with that, but it was there, very interestingly. So the commands I can do, very simply, you can change the directory, you can find out what current directory you're in, you can list the files within that directory, you can download a file, upload a file, list the mounted disks, which is interesting, and you can execute commands. So honestly, pretty much everything that you need for like a backdoor. So we managed to find a Windows version by pivoting off the C2 address. If you remembered the addresses that I had highlighted before in the configuration slide, from that we found what was a stager. And a stager was using PowerShell to download a DLL and then execute this DLL in memory, as sort of fileless malware. And we found out that this DLL is the Windows version of Vermilion Strike. And the DLL is actually from 2019. So if any of you guys know the researcher, Silas Cutter, he actually posted a tweet about it years ago saying like, hey, this is an interesting copy of Cobalt Strike, but it turned out to not be Cobalt Strike at all. Yeah, the functionality between the two versions are largely the same. So what I have nicely here is like an IDA graph. On the left, you see the Linux self version of Vermilion Strike, and on the right, the DLL. This here's the configuration decoding function. So yeah, if you bring them up side by side in IDA, the Windows and Linux versions, they look pretty similar, so they do. So in the wild.
Thanks. Okay, so we partnered up with McAfee Enterprise ATR. We provided them IOCs, and they queried their telemetry. And we discovered that Vermilion Strike was part of live attacks on high-profile companies around the world, government agencies, telecom, advisory, financial institutions, and IT companies. With that being said, the amount of victims was still kind of specific. Okay, so we didn't found many victims, as well that we didn't found many samples. As for the attribution, so we know it's a backdoor. We know that it's written from scratch. We know that it targets Windows and Linux. And we know that Vermilion Strike was targeting high-profile companies around the world. So based on our historical knowledge, we can assess with high probability that Vermilion Strike was developed by an advanced adversary, most probably a nation state. However, we didn't attribute it to any specific nation state. Now, the Windows version of Vermilion Strike had a decent amount of security vendors detecting it in VirusTotal. However, the Linux version had none. And this raises the question of why Linux malware fly under the radar. Let me show you this screenshot taken from Ubuntu's official website. The title is, Do I Need Antivirus Malware? And I marked down 2 sentences. First sentence is, I'll read it from here. Antivirus software does exist for Linux, but you probably don't need to use it. Second sentence, whatever the reason, Linux viruses are so rare that you don't really need to worry about them at the moment. Now, this misconception causes for less demand for Linux detection, which shifts away security vendors from spending time and resources on Linux detection. And this leads to these situations, okay? This is a sample of Mirai botnet. Mirai is one of the most common botnets kind of ever, okay? Its source code was leaked a while ago, and the developer of this sample added a spice of sophistication, and they obfuscated some strings and function names, okay? And this is the result. None of the security vendors in VirusTotal detected it, and I find it really concerning, okay? We really should care about Linux malware. We at Intezer, we find Linux malware undetected all the time, and we continuously report about it. We just published a report about Symbiote, which is a Linux rootkit, also found in live attacks. So I really hope this is one of the takeaways from our talk today for you guys.
So sort of detection and response. For the Windows version of Vermilion Strike, it needs to be detected in memory. You know, it's a fileless payload, so your EDR, antivirus, endpoint scanner, whatever you're using on your endpoints, make sure that that can deal with fileless code stuff in memory. But you can also detect via the stager too for Windows. What we noticed is that the stager, it was uniquely developed, so it had that sort of similar situation where we had not seen the code used anywhere else. So if you find that particular stager, you can probably also go, okay, there's a good chance that there's Vermilion Strike. We haven't seen that stager download anything else and execute that in memory, even though it has the ability to. The Linux version, you can just find that on your disk. So technically, it should be a simpler task, but as Avi talks about, there's not the sort of same amount of detection for that around there. So some Cobalt Strike methods for detection can be used for Vermilion Strike as well. You saw on the slides like the Yara signatures that Florian Rolf had made. You know, you can detect like the configuration. It's the same as the Windows. Or even you can detect it via the network. You know, if you have ways of fingerprinting, like Cobalt Strike C2 servers or sort of communication artifacts, you can find that too. That'll be the same as Cobalt Strike. Predictions that come from that. Cobalt Strike, it'll probably remain to be a big issue for Windows. It's still extremely popular. You know, it's still being maintained. There's new versions coming out, and because there's new versions coming out, there's new cracks for it, and yeah, it's going hot as ever. So I think it'll keep being a big issue for Windows. Vermilion Strike, I would say it has a unsure feature. You know, we found it targeting organizations around the world, you know, stuff in government and all, but it wasn't an insanely huge amount. So in a way, we don't particularly have the telemetry to find out, you know, what the future for that's going to be. as you saw, the Windows version was still live from 2019. The C2 have been serving that payload for years. And we see the cross-platform malware will continue. Again, we're finding those all the time. We even found stuff that, for targets Mac, Linux, and Windows. So yeah, there's still the incentive there. People are moving to, again, the march to cloud continues on. People using Mac still, and there's going to be stuff with the M1 chips, so you can see ARM versions of malware and all. We think that'll keep happening. And with that, thank you very much. There's a QR code to the blog. Please read it. It's got IOCs, everything you want. Again, you want to find out what the stager looks like. You want to find IOCs for the malware and the network IOCs. Please read the blog. It has loads of technical details. And please, I invite, if you have any questions, please, we want you to ask us.
Thanks a lot. So these fine people will be available for questions later if you have some. I see one now. Yeah. Oh yeah, we do.
Oh yeah.
Right. Question about I totally agree with your assessment about the lack of attention towards Linux, and I've been thinking about that myself a lot, running virtual machines, etc. And sort of the best I came across was Rootkit Hunter and things like that. Is there some willingness and some effort to actually push to those existing easy sort of AV light systems for Linux, or how do you recommend approaching the problem that you're identifying?
If I understand your question correctly, you ask how to identify Linux malware.
No, how do we bridge that gap that the problem, there's almost no detection software by default in Linux in there, so yeah.
So I can take that, or?
Yeah, you said that, and then I can add.
So basically, Windows, when you buy it, you have Windows Defender, and there's a huge industry for endpoint and EDRs and so on. They also, the EDRs also can run on Linux, and this is kind of the CISO's work. If you need to map all the machines in your company. Do you have servers? Which endpoints do you have? Do you have Mac? Do you have Windows? Which percentage? And make sure that you have coverage. And there are solutions for everything. I believe not for everything, but there are many solutions. So it's kind of the security posture and the assessment of what you have. Yeah,
I don't quite agree, because Linux, as you pointed out, is really everywhere. Lots of it is in the cloud, but also another big user base for Linux is embedded systems. And embedded systems, you can't run a full EDR on top. The update cycles are different, et cetera, et cetera. So we need something else, and that's why I'm wondering, how do we address this problem?
Yeah, so I'm not sure what's the industry for embedded systems. I know that there's industry for, servers running Intel and, 64-bit. We also have a tool in Intezer, which is called Protect, for these kind of matters. Do you want to take that, or?
Yeah, it's sort of, it depends how creative you are. I know some people, again, we have a product, I won't talk about it too much, but, we have things that scan, in memory, to detect code. I know some other vendors have tried stuff where they'll take, an image, of their VMs and then sort of, try scan, those sort of snapshots of images for malware. I know there's stuff like ClamVM. What I think is very interesting is that, for Linux, there's not too many sandboxing solutions. And what can also especially get hard, if you take Vermilion Strike there, that particular sample, it was compiled for CentOS or Red Hat. So if you were trying to run it in a Ubuntu sandbox, it would sort of brick itself. So it's almost like you need very good sandboxing solutions, but for different sort of distributions, it's sometimes hard to get things to run. So. Yeah, if I were to say that the best way is our product, but it depends how creative you are. I would say to sort of bridge that gap. I wouldn't say I know the perfect way.
Okay, thanks.
Thank you. I guess the perfect way is to talk about it, you know, start a discussion
It's an interesting
first.
question. Yeah.
Start a discussion.
Yeah, hello, Didier Stevens here. I have a question about the protocol. So I understood that it implements a subset of all the commands that you would find in the Windows version, so not all the commands are implemented. Is that correct?
I would say so, yeah, it's like a sort of minimal version.
Do you have an idea if a command like port scan, if they implement it, and I'm asking this question because in the protocol of Cobalt Strike, if there is something like a port scan, the standard Windows beacon has no functionality to do the port scan. So the team server will send over a DLL that is able to do the port scan. So there's extra functionality being sent over. So that's in the commercial version. You know if something like that is implemented in Vermilion, if they send over an ELF, for example, for extra functionality?
I think I know what you mean. Like they'll send down like the tool that's able to be used.
Yeah.
No, we didn't see that actually.
Okay.
So there's the commands that can be run, and then I think everything else. It's if you can do it within a command that you can kind of run in like the terminal. That's just like execute a command.
And have you seen commands implemented that are not existing in the commercial version?
I'm not sure if like the get the mounted disks, is that in the commercial version of Cobalt Strike? I thought that one was quite interesting.
Okay. Thank you.
Thank you very much.
Hi, quick
Hi.
question. So you said on Linux, it does drop a file on the system. Do you think it could go fileless in the future? Is it possible on Linux to do so?
It's possible, yeah. I don't really see that happening, where there's stuff like, say if it's packed, so there's like Zuri packers, for example. If you pack it with a Zuri, that will technically make it fileless. But I would say that there didn't seem to be any incentive to. Like when we found it, it was 0 detections, and and honestly, there's not even really any other obfuscation techniques. It's not like it's installing rootkits and then removing it from like the process list and all. Like it's in some ways like kind of basic. So I would say I don't see it happening.
Okay.
For fairness.
Thanks.
Thank you very much.
Yeah, short question. My experience in the last 13 years as IBM researcher in the X-Force team, I analyzed several botnet attacks, and I find most of DDoS attacks are also currently available or running at the moment come from embedded devices. For example, cameras, digital video recorders, old Soho routers, and something like that. And I think the biggest problem that we have is this hardware or the firmware of these devices are never updated, and you can find very easily default username password databases on the internet. And if you monitor such devices, you can see permanently scans, port scans, and if they detect something open on such a device, the botnets have a war against each other botnet to get access to the device. And mostly cameras. I see a lot of cameras in the Asia Pacific area. These devices are installed, set it and forget it. That's, I think, it's my thinking, the biggest problem for DDoS attacks the last years and also at the moment. Did you agree with this?
We do not really focus on these kind of infrastructure, but we see many, I see many publications, and also we see many botnets that are coming to our systems that are ARM, for example, that can run of these. So it's very common. as that you said before, they scan the net, they use default credentials, maybe password sprayers, vulnerability exploits, and so on. Yeah,
Okay.
can agree.
Thank you very much.
Thank you.
Right there.
One question.
Oh, yeah.
Yeah,
Sorry.
this
Oh,
is-
yeah, thank you.
Have you seen how far it will be effective by analyzing the DNS request and response? Can you generate some patterns based on these Cobalt Strike beacons for network indicators, a pattern of DNS request and response? Has there been any implementation like that in the security community, at the IPS or firewall?
If I'm sort of, let me go back a few slides, maybe to where I have screenshots of the answer, and I'll try to figure out. I mean,
Yeah, that one.
So here, so are you asking sort of maybe you could get like this pattern if you saw, you know, these types of queries in sequence
Yes.
that you could detect that? Yeah, I would say you could do that. You can probably do it with Snort and Suricata. So what's interesting about this is that you'll see that, you know, this is the C2 address here, but
Yeah.
so these numbers beforehand, this is actually a randomly generated number, so they keep that, but then they sort of will change stuff. So a lot of these were in the config. It'll be, you know, Apple, that, and there's, you know, there's Apple, Facebook. There was kind of sequence of which that would run. So I'd probably say yes. I would say maybe the best way, Snort and Suricata. I think you can add a sequence in there, if I'm not mistaken.
Thank you.
Thank you very much.
Thanks for those good questions. I see we're out of time. So with those last words, I say thank you again to Intezer.
Thank you very much.